let us look at 2018 number 5. So for the first question, number 5, let f be the function defined in this way, okay? And then find the average rate of change from here to here. Now, when they say average rate basically same thing as finding the slope of the secant line. So to figure out value of, to figure out part A, what I'm going to do is f of pi minus f of 0, so change of y's, divided by pi minus 0. So when you plug in pi, then we're going to get e to the pi and cosine of pi. Since I don't have much space, I'm going to move them. Over here, okay. Cosine of pi minus e to the 0 cosine of 0 over pi. Now, what is cosine of pi? That's in fact equal to -1. So first part of the numerator becomes negative e to the pi. E to the 0 becomes 1, and then cosine of 0 equals 1, so minus 1 over pi. That becomes your average rate of change. All right, let's look at part B. I'm going to write down part B on the bottom here. What is the slope of the line tangent? That means we need to figure out the derivative. Since we see two expressions multiplying each other, so what we're going to be doing is we're going to use the product rule. So we're going to get f prime of x is equal to e to the x times cosine of x. I just took the derivative of e to the x, which was e to the x, plus e to the x, and taking the derivative of cosine, we get negative sine x. Now, but the value of x is 3 pi over 2, so we get x equals 3 pi over 2. Then you can see that we can factor out e to the x from both parts, so e to the 3 pi over 2. And cosine of 3 pi over 2 minus sine of 3 pi over 2. And cosine of 3 pi over 2, you realize that that's equal to 0. And then sine of 3 pi over 2 is -1, but with another negative, it becomes +1. So our final answer becomes e to the 3 pi over 2, as it is. That becomes my answer. Alrighty. Now, part C. To figure out part C, find the absolute minimum. Now, in order for you to find the absolute minimum, what we need to do is we need to set up the table, and then 0 beginning, and then 2 pi, and we need to figure out if there's any critical points. To find the critical points, we gotta use the first derivative equal to 0. We have done that last time here, so we get f prime of x has to be equal to 0. That means when I factor out e to the x, then we are left with cosine of x minus sine of x. Of course, e to the x could never be equal to 0. Then cosine x minus sine x could be equal to 0, so then I'm going to write that down. Cosine of x minus sine of x equal to 0. That means sine of x is equal to cosine of x. And when you divide by cosine of x, then you get sine of x over cosine of x, which we know that to be equal to tangent of x equals 1. Because cosine divided by cosine equals 1. Then when do you have tangent to be equal to 1? Oh, x has to be equal to pi over 4. It's in the first quadrant. Or it can be in the third quadrant. Hence, we get 5 pi over 4. So we have two values. So pi over 4 and 5 pi over 4. All right, so we have 4 values here. And what I'm going to do is I'm going to find out the value f. For the first one, when you plug in 0, you get e to the 0, which is 1, and cosine of 0, which is still equal to 1, so we get 1. Pi over 4, then we get e to the pi over 4 and cosine of pi over 4, which is equal to radical 2 over 2. So that's bigger than 1. Now, 5 pi over 4. So I'm going to put e to the 5 pi over 4, which is pretty large number. And then cosine of 5 pi over 4 is negative radical 2 over 2. Now, lastly, when you plug in 2 pi, then we get e to the 2 pi, which is pretty high. But what is cosine of 2 pi? That's equal to 1. So, and then they're looking for absolute minimum. Then absolute minimum value would have been this one. So we get absolute minimum is negative radical 2 over 2 times e to the 5 pi over 4. And you can see that right over here. Alrighty, now let's look at part D. I'm going to do part D over here. Let g be the differentiable function such that g of pi over 2 equals 0, okay? And then graph of g prime, the derivative of g is shown below. So this is a graph of g prime right over here. And then that's what they want you to do. Now, so when I try to find the limit of f of x over g of x as x approaches pi over 2, first thing which we get to is when you plug in pi over 2 into the original function, because cosine of pi over 2 is equal to 0, our numerator becomes 0. But denominator, they told us that that's equal to 0 already. Then we get 0 over 0, so we have to use the L'Hopital's rule. By the L'Hopital's rule, this expression has to be equal to limit of f prime of x over g prime of x. It's x approaching pi over 2. Now, I think we can easily figure it out that f prime of pi over 2 is equal to e to the pi over 2 times cosine of pi over 2 minus sine of pi over 2. Now, then cosine of pi over 2 is equal to 0. And then this one becomes negative 1. So we get negative e to the pi over 2. Now, so then, let me move this one to the bottom a little bit. So we figured out that my numerator will be equal to pi over 2, or negative pi over 2. A negative e to the pi over 2 rather, sorry about that. And denominator is when g prime, right here from the graph, of pi over 2 becomes 2 right over here, so I'm going to write that down. So therefore, what is our final answer? Our final answer is right over here, negative e to the pi over 2 divided by 2. All right, so with that, we are done for number 5. I'll see you later.